Okay, this is part 2 of exercise 1.61. So this is similar to the one before, but a little bit different. U is a vector. This is a vector that is in Rn, and we're going to define a function from Rn to Rn given by the following formula. So L applied to the generic vector V is just U dotted with V times U. Okay, so you're doing U dotted with V times the vector U. So let me just mention something. If you've taken Calc 3, for example, even probably you've seen this in Calc 1 here, though I don't remember exactly. This is very similar to the projection of the vector V onto the vector U if U is a unit vector. So if U is a unit vector, this would exactly be the projection of the vector V onto the vector U. Okay, that's what it would be if U and V were in R2 and U is a unit vector. But actually, this is more generally, if U is a unit vector, this is also the formula for the projection of V onto U. But we'll get to that later. I just wanted to connect this back to things that you might have already seen. Okay, so I want to prove that this is linear. So what we're going to do is we're going to use the previous example. We're going to use the previous example and write this as SV times the vector U, where S is a linear transformation. SV is equal to U dotted with V. Okay, we proved that in the previous example. Okay, so L applied to C1 V1 plus C2 V2. What is this? Well, this is just going to be equal to C1 V1 plus C2 V2 dotted with U, and now I'll put brackets around this, times the vector U. Okay, but what is this inside the brackets? This is just S. Sorry, let me make this a little more clear. What is this inside the brackets? This is just S applied to C1 V1 plus C2 V2 times the vector U. Okay, well, we already proved that S is linear. So this is just C1 S V1 plus C2 S V2 times the vector U. Now we're going to use the distributive property of scalar vector multiplication. So notice that this quantity inside the brackets is a scalar because S applied to a vector is a scalar. So C1, that's a scalar, times SV1, that's a scalar. So that's scalar multiplication plus C2 SV2. Again, this is C2 times SV2. That's scalar multiplication. And that plus is scalar plus. So the thing inside the brackets is a scalar. So this is C1 SV1 times U plus C2 SV2 times U. But remember, this is just C1 SV1. This is just U dotted with V1 and then times U, and then similarly this is C2 times U dotted with V2 times U. In other words, this is C1 LV1 plus C2 LV2. Okay, so what does this tell us? It tells us that L applied to C1 V1 plus C2 V2 is equal to C1 times L applied to V1 plus C2 times L applied to V2. In other words, it tells us that L is linear. And notice we use the fact that the dot product is a linear function. That's what we proved in the previous problem, and that's what we used in this problem.